problems out of that to go through and then go on from there. Yes. We don't call it that, we call it hypotenuse. So when we're talking about all the different ways that we have to show that triangles are congruent, excuse me, we have the side, 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 angle, side, angle, side, angle, 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 side. We had all of those. But the new one, or the one that we haven't talked about, is one that's called hypotenuse leg. So when we talk about what's called hypotenuse leg, you have to remember what kind of triangles have, or what's the only type of triangle that has a hypotenuse. It's a right triangle. So when we define this out, we define out hypotenuse leg. This only it only works with right triangles. It's the only possible way this will work. So we're talking about right triangles. Remember, which part of a right triangle is always going to be the hypotenuse? The side that's longer than the other two, but how can you identify it from a diagram? That's what I was getting at. It's always the one that's across from the right angle. Okay, it's the hypotenuse is always the one that's opposite the right angle. So your right angle always looks at the hypotenuse. Okay, the other two sides are just called legs, and it does not matter which one is which. Okay, so those guys are your legs. Now, as you get into this, what happens with this, in order for this to work, what happens is you have to have both hypotenuse congruent and one of the corresponding legs congruent. If that happens, then the two triangles become congruent. So let me see if I can draw this out. You guys remember what that real big theorem was in geometry about right triangles? The Pythagorean theorem, right? So if you have the Pythagorean theorem, do you remember what it was? Okay. So what's your A, B's, and C's? Do you remember which one's which? No. What value is always going to be the value of C? It's the hypotenuse. Okay? So let's do this. Let's call this C, A, and B. Now, if you happen to know, and I'll do this numerically, let's say we have, excuse me, a 10 and an 8. And let's say this is also a 10 for C and a B, a 10 and an 8. Are those two hypotenuse congruent? Yeah, they're the same measurement. They measure the same. They both measure 10. So these two are the same. Do the two corresponding legs measure the same? Yeah. Now, the reason why hypotenuse leg works is because of that whole thing of a squared plus b squared equals c squared. So in this case, this is angle side side. But like we said before, there's no axiom math, but there is hypotenuse leg. Now, what happens here is that if I fill in the blanks here, I get a squared plus 8 squared is 10 squared. What's 8 squared? What's 10 squared? 100. So I get this. A squared plus 64 is 100. If I subtract 64 over, I get a squared equals 36. What's the square root of 36? 6. Now, doesn't that have to be 6 for both sides? Doesn't this have to be 6 here? And that means this has to be 6 as well? Because it's the Pythagorean theorem, because it's a right triangle, this is one of the things that occurs that you don't necessarily have to have all 3 sides or have it as a side angle side that works, because you can work backwards to get it via the Pythagorean theorem. So that's why hypotenuse leg is its own little standoff thing. That's why we can say just HL. Does that make a little bit of sense? I just wanted to, I figured I'd show you guys why it actually works. It's not something that they really show in a textbook. It's along the same lines as you could have done all of that work to get side angle side just by using Pythagorean theorem. Because I could have had the 6, the right angle, and the 8, and it would have been fine. But since right triangles will always, always, always pass the Pythagorean theorem, that's why hypotenuse leg works. Yeah, we threw a hypotenuse leg on there, just a little picture of it to show what it happens. And I think we also made a note that no matter what, this only works for right triangles. And it can only work for right triangles. Okay. Not so bad. So let's do a proof. Excuse me. Let's try a proof on it. So we have our givens and a proof. And I might do one extra step instead of just the proof triangle. Bless you.
Thank you.
Bless you. Now, when you have your progression sheet like this, when you have your progression sheet like this, what does it say to do when you're given right angles? After it says that you've got right angles, what does it say to do? Well, look at your sheet. What is your? None of you guys have your progression sheets out. You should have those out. Come on, guys. Well, what's the reason? Yes, that's where we're getting at. Then obviously mark the diagram. So then you can say that those two angles are congruent. All right angles congruent. Okay. Now, when we've kind of alluded to this a lot. Whenever you write something down, and after you get to the point where it says that something's congruent, that usually means you're done using it. There's usually not much else that you say after it, unless you're getting to, after you've done triangles or along those lines. But at this point, you had a definition. You were told that you had right angles, which means that they have to be congruent. So now you just go to the next part. The next part says, excuse me, SP congruent to QR. Marked our diagram. So right now, when you look at it, I want you guys to remember that just because there's a right triangle doesn't necessarily mean it's always going to be a hypotenuse leg, but it's something that you should always just double check real quick. So in this case, what is SP and QR? What are those in those right triangles? They're both the hypotenuse, okay? So what do I have left to find? Another leg. Where's the leg? Yeah, the reflexive property. Good. Oops, I pressed right given here. So I have my reflexive property of PR. Mark my diagram. And what do we have? We have the hypotenuse leg. So triangle PRS. RPQ. by HL. HL is fine. You don't have to write any of that out because if you think about it, all the other ones we've done, they're just letters. You don't have to just continue with that. What happens if I asked you to say, how would you write S is congruent to Q? What's the reason? Good. And again, that's kind of what we're getting towards, guys. It's just another way to show that the triangles might not be incongruent. And you can still do that one extra little step towards the end of it as well. Okay? And hopefully it's not so bad. We hope. Okay? Oh, that was supposed to be a B. That's it. Okay? Try this one. Got a bunch of different parts to it, little extra writings. How this goes. This one takes a little bit longer because of all the extra perpendiculars that are thrown in there. So BE bisects AD at C. Okay? Now that means that AD was the one that was bisected. So that tells you that you have segments AC and DC that are the same. Definition of a segment bisected. Go to the next. AB is perpendicular to BC, which means what's created at that intersection? Right angle. So you state the right angle that's created. So is it okay if I just say angle B is a right angle? I can do that because there's only one vertex for B. So it's just a little, writing it out a little bit less. Angle B is a right angle. Definition, perpendicular. Now I can't say that it's congruent to anything yet because I haven't defined that there's another right angle. So this is the time that you actually have to write down both of those separate givens to write out the step first. Angle, so what was the next one? DE and EC. And then we said angle E. Now you can say that B and E are congruent. All right angles congruent. Okay. So back up top then, oh, we have one other given, AD is congruent to DE. Now, if you look at your diagram, what do you have? I just like, because you've got right triangles, you've got the right triangles, you had this hypotenuse, the AC and the DC, then an AB and DE. So your two triangles are congruent then. Got the lettering. What's it? ABC, DEC. The way everything works is it's all setting up the exact same way, ladies and gentlemen. None of that changes up at all. It's just a matter of following a progression and seeing where it leads. One more. Don't get it out. guys. All right. So this one's a little bit trickier. Sort of. Ladies and gentlemen, draw this one up. This one's a little bit trickier because now what's going to happen is that you have, you're going to be given something a little bit different. In this case, you're given that you have an isosceles. It's a little bit extra different for you. To draw this one out, let's go in. Excuse me. Now, if I'm not mistaken, guys, if I'm not mistaken, in one of our squares, we talked about isosceles. Okay. If I'm not mistaken, in one of our squares, we talked about isosceles triangles. We wrote in there, if, then, and then I think we also had if, then that. Oops. Is that correct down there? What's different about this is that since we have an isosceles triangle, what can you say? What do you know about isosceles? What's that, sir? G, that's it. GK and EK. I think you said J. Handwriting's bad. Yeah, and that's what we're getting at. So this is a little bit of a different one. Okay? Every once in a while you might have a little subtle nuance. In this case, what we wind up with is by starting with your proof. Excuse me. These real quick. By starting this one out, saying that triangle GKE is isosceles. That means in my diagram, I can do that. So I would say GK is congruent to EK. What do you think my reason is? Exactly right. Exactly right. Definition of isosceles. Okay. Next given says L and D are right angles, so we write it out. So what should I do to my diagram? Put the little right angles in. Okay. Which means that they have to be congruent. All right angles congruent. And then the last given is that you have a midpoint. If K is the midpoint of LD, what happens? So we have LK, AD. And then again, go back up and mark your diagram. Do you have congruent triangles now? How? Hypotenuse length. This works for hypotenuse length. Yes, ma'am. Where is the reflexive property that between those two right triangles? What's that? Yeah, in this case there's no reflexive property between those two because you're trying to get to the triangles, the right triangles like that. So it's not going to work itself through. So what happens now is you've got your triangles, GLK, EDK. By hypotenuse leg. And then lastly, I think it said to go and say that LG and DE. And what's the reason? There you are. Okay. This is the complexity of, as far as these things are going to get, guys. They really don't get any trickier than this. They really don't. You have 2 or 3 givens, simple progression out of it, and this seemed like it was a lot of steps. 1, 2, 3, 4, 5, 6, 7, 8, 8 steps. But honestly, of the 8, you really only had to come up with really none of them. They were all drawn right out of the givens here. Only thing you had to figure out was how we're going to get to it. So just by marking the time. And that's all the stuff goes. No, I wanted it on the proof. I forgot that I had it on. I thought I didn't save it onto my new computer. That one. Ladies and gentlemen, we have work in front of you. Is as I write down angle 1 and angle 4 are the same, I'm going to put that in my diagram as I'm writing it out. LM perpendicular MP. What happens when things are perpendicular? You get 90-degree angles. Good. So we put in my right angle, angle M. Same deal. OP and MP. Right angle at P. Okay. What do you know about 2 right angles? They're going to be congruent. So then we would have to say that M and P are congruent. You move this up. Okay. And then lastly, you have N bisects MP. If a segment is bisected, what's created? Two congruent segments. So N bisects NP. You got to make sure you have a segment bisector, not an angle bisector. And now we go back to our diagram again. How do you have triangles congruent? Angle, angle, side. There's no hypotenuse there, but you have angle, angle, side. And that's the idea. It's not always will right angles automatically give you hypotenuse leg, okay? So your triangles then became, excuse me, forgot the letters. L, M, N. Yes, ma'am. Nope. As long as it's consistent with the other one, as long as they match up, it's fine. Okay. As long as, because my congruency statement, the way I wrote it, that means that L and O have to be the same angles, M and P have to be the same angles, N and N obviously are the same angles, the same letter. So that's why we do the congruency statements. As long as they fit, lettering doesn't matter. And then last, I think it was what, LN and ON. I think I put the homework on the calendar already. Okay. So what I want to do here is page 262. Numbers, what did I write down? 10, 11, 17, and 24. There are 5 of them.